I suppose the participants are recorded by Miteco?
Yes. We don't, it will be on the slides, but we don't have to record the participants.
Okay.
I just realized that today is the 80th anniversary of Pearl Harbor, right? It was 80 years ago. So it's pretty much the 5 after the hour. Not there yet, but I guess we can start because we have a lot on our plate today. Sidgar is here, Anna is here, Laura is there. We are still missing a few people. Let me start doing the usual introduction, and hopefully the people who are missing will join if they plan to join at all. So, hello all. This is an official IETF interim of the LPWAN working group. So, welcome all. Usual note well. As you know, we have always played this note well with a focus on the patterns. So, if you're aware of any IPRs being discussed today, and that was not announced, please announce it or let the chairs know. But the IETF is also very concerned with other misconduct, such as harassments within the working group. So be very aware that there is a best practice, and there is a special group called Ombuds Team, with the link given in this page. If you have some problems related to harassment, you being harassed, or you see people being harassed, please let the Ombuds team know, and the IETF will act on it. Classical reminders, the minutes are being taken. If you can visit the link that's in blue in this page, it's actually 13, sorry, there's a typo. This is the CodeMD. I already shared it in the chat. If you need it, I can share it again on the chat. and the presence is logged automatically by Mitico. So we don't have to maintain the list of the people anymore, which is a great service by Mitico. Agenda for today, and sorry for the presentation, it's just the way the system has uploaded my PowerPoint into PDF. So we'll do the classical administrativia, then we'll discuss the architecture document, an update was posted. Then Anna will, or Edgar will, oh, Eric, do you want to say something?
Yeah,
Go ahead.
Yeah, and basically you can imagine what I want to say. It's basically about we need to get a scribe, a minute taker.
Yes, we asked Anna already, but I was giving the codee to make sure that anybody who wishes to help will effectively, and I will take notes as well, to be honest, Eric.
Okay, perfect. We can go on. Thank you. Thank you, Anna. Thank you, Pascal.
So 10 minutes on the LP1 architecture. We already got some questions by Olivier. So if Olivier joins, then we can discuss his points. Otherwise, I'll try to do my best by memory. Then Edgar and Anna will tell us about the delay tolerant pram and FUTA, which is the firmware update over the air and all related primes. And then we'll see with Laurent the state of the Yang module integration and the data model document. And that should be it for today. So we had basically two action items. Alex and I were in charge of updating the architecture, which we did. And Laurent, there was some text in the data model that was related to the Sigfox improvements of Sheck. And we decided that they should be in a separate document, so you were supposed to take that off. Did you work on this, Laurent, as part of your changes?
Yes, it has been done. So the new version of the draft has nothing to deal with OIM and Componac. So this has been done. And the module for Componac is on the repository, and Juan Carlos has to integrate it into the document. And the part also for OIM has been
extracted
and have to be also, we can work on it.
Very well. Thank you very much, Laurent. Work group status. So here are dates, and you can see that Chic over Sigfox is now a little bit overdue. We are supposed to publish LP1 Componac first, and we don't really have a milestone for it. It's kind of, the split of the Sigfox. So the question here is, Eric, should I enter a milestone? Is it really necessary, or do we consider that the two documents are kind of one?
Honestly, that's okay to get one milestone for two. Now, the milestone is a little bit...
It's just for us to remember mostly. Yeah, okay. So we don't change the milestone for now. The Sigfox document, we expect it very soon anyway. I don't see if there is value to change the milestone. Okay, next slide. So the document advancement. So as you can see, the data model and the LP1 architecture were freshly republished. And well, in BIOT, we expect one at some point, but maybe after the discussion we'll have today, whether we need to integrate a DTN or not. That's pretty much it. Nothing new. We are missing updates on the OAM. So, Dominique, do you have any plans? Oh, Laurent, you wanted to say something. Go ahead.
So Dominique talk, and I will do after.
Okay, Dominique, do you have any news about the OAM? Any plan? Dominique, you're muted.
Yes, fumbling for the mute button. Sorry. Hello all. Yeah, my plan is to resume work on it quickly.
Good plan. Okay.
Sorry. Yeah, nothing more that I can say. No excuse, except busy and
Then
so many things.
You may have to talk to Laurent about the data model piece of OAM, I guess.
Yes, I must say we talked yesterday, I think.
Oh, so it's moving on. That's great. Laurent, you wanted to say something?
Yes, I see in status that you have reviewed the young doctor for the data model. Is it new or it's something that I missed before?
That one is for Eric, I guess.
No, I think this is Laurent. I think this is the one we requested that actually Pascal or Alex requested months ago. So nothing is new as far as I know. That's not really the old one.
Okay.
Tracker doesn't track so much this.
So that creates this entry. I was curious to see it as well. So that's interesting. Okay, thank you, Eric. Thank you so much. And actually, we did it, thanks to you, because we are not used to that procedure. So many thanks for helping us through that. And that's pretty much it for the Trenda bashing, etc. So let's move to the architecture. So like I said, 01 was published. It's kind of an interesting change. I mean, there's a not huge, but important change to the document. We reshuffled it a little bit, so the order is a little bit changed. Now, as you can see, the main points are applicability. Then we discussed the architecture itself with the endpoints and the layers. Then we have some words on the data model. And we've got this new section on the life cycle. That's the one that was discussed on the mailing list with Olivier today. And so we thought that we needed to wrap the data model with some text that explains where it comes from and how it's being used, how it's being published, etc. And that's why we have this section 7. So it's not really architecture, which is 5, but it's basically all the life cycle. Olivier was concerned that it seemed to add requirements to the development cycle, and that's not really the idea. The idea is, if you want to follow this life cycle, which you don't have to, right? It's an informational document, it's a lowercase should, but if you want to basically to have the next steps, like the publication of the rules and then the availability and signature and all the securization of the rules, etc., which are described in this life cycle. If you want that, then at the time you develop the device and decide which messages it's going to exchange, certainly that's a good time for writing the rules, basically. So that's why we effectively have a 7.1 about the device development. It's not saying how you could develop. It's saying you probably want to produce the rules at that time, so they can be published in 7.2 and available with the device deployment, etc. So this is very early text, but I would really appreciate that people go through that to see if that's the kind of way they thought that the rules could be deployed for a classical device, so low-power device. Shake is not only for low-power device, so that's really the use case of low-power devices. If you have big iron switches doing shake, which they really could, hopefully they could have other methods. But for devices, it makes a lot of sense to basically prepare the rules during the development and make that available across the web or on external servers, etc., and provision that into the network at the time the first device is actually instantiated. So that's why we have this section, what it describes. Again, it's not there to say here is how it is. It's there to steer the discussion. Eric, yes?
Oui, Pascal. Sorry, Pascal. I was about to speak in French to you. Can you go back on the slide, the previous slide? So there is one thing that you need to add back is the IANA consideration. That's mandatory, even if in one line there is no IANA consideration, it will be removed before publication. That's a detail.
Yes, I just wonder why it's gone, actually.
Yeah, okay, but okay, there's a mistake. It happens, right? We'll blame it on whatever tools you are using.
It will come back. It's magic, disappear, reappear. Magic.
Yeah, exactly. With Christmas period, right? So now, with all the consideration to Anna and Laurent, I'm not sure whether the data model is really important in this architecture draft. You can leave it, right? But I wonder, is it really needed?
I think it's a very short section that describes what it is, because we'll need that in section 7. But now section 6 could be effectively merged into section 7. I don't know. It describes that we have a data model, and that's how the rules are expressed. And once we have that, I mean, it's not a big text anyway, but yes, I guess we could remove it. Laurent?
Yes, in a previous mail, I asked maybe we need a place where we can have a list of data models that are related to SHIC. So now we have the main one, and we have augmentation for component ACK and soon OAM. So maybe it will be good to have a place where we list all the extension to the basic data model.
That's an excellent point, Laurent. And let me tell you what we are doing at Row. Initially, we had a document which was both architecture and framework, and trying to mimic a little bit, but it's never perfect, what .NET does. .NET published the architecture very early in the process. And the architecture says, we don't know exactly how, but here is what it's going to do. And here is what it's going to be. There will be those main components, but we can't tell you which RFC because they are not even written. And later down the road, once things stabilize and we have the drafts, etc., then we do a framework, which basically says, here is how all those RFCs and all those documents work together to actually implement the architecture. So in my mind, what you're asking is on the latter type of activity, the framework, more explaining how things are together and what was produced, versus the architecture, which is more, here is what we're going to do. Here is how it's going to articulate. But at this time, I can't tell you which RFC or anything because they are not there. And so if we have two choices with this document. Either we do what you say in section 6, but then this will be architecture plus framework, and we'll have to delay till the end of the working group to publish it. Or we do what we just did in Row. We split the document into pure architecture. Here is what's going to be, here are the components. And framework, here is how we did it. Here is how those RFCs are articulated to implement the architecture. And now the ball is in the camp of the group. I mean, what do you guys want to do? Do you want one document at the end, or one early and one late? How would you prefer? Any opinion? Was I clear with my question? Laurent?
Yes, I think that for the architecture, we are learning when we are doing so. I think now we don't have the same vision of SHIC as we had at the first meeting, and the architecture is more and more
stable,
complex. And so I don't know if we can write a document before and it will be true at the end.
So what you suggest is we do what we did in 6-ish, which is effectively publish architecture plus framework at the very end of the process.
From a point of view, I think it would be more accurate.
In this case, the thing that you're asking, in this case, the thing that you're asking a repo, a place to explain what the data models are, could be this section 6, in which case it would remain. To Eric's point, it's not part of the architecture, but it's part of the framework. And so if we turn section 6 into a framework, then there would be a data model and all the optional pieces that will be the components that will be added. Does that make sense? Is that the way you would like to see it?
From my point of view, yes. And the draft is available for everyone, so it's not something that is hidden during the
yeah, no, it's
process.
okay. So any other opinion? Dominique, Juan Carlos, Edgar, Anna. Okay, so I'm good with what Laurent says. For now, we will not split. I will turn section 6 into framework. And there will be one subsection of framework, which will be the data models, which will have to describe the various, the main and then the various optional components that fit into the data model, I guess. Okay, and that's not totally it. So what's missing? We are missing already some sections that are there, but they are not filled. We want to have some examples. And there was the example of Goose, which came to mind. Goose is a smart grid protocol to control the smart grid. I'd like to see reviews and discussion, especially on the life cycle, and that has started with Olivier. Probably we want to explain more about the DTN discussion we'll have today and the firmware update over the year. And then in this life cycle section, there is a little bit of discussion about key management. And when do you publish the keys of this device in the network, in the application? When do you publish the rules in the network? Is it the same time? Is it related? Is it, how does that happen? How is that done together? So that's what's missing. We'd like to see discussions on this. And that's pretty much it for this piece. So yes, I guess I'm a bit out of time. Any question, any more discussion? Otherwise, we'll go to the list. And the next piece in the agenda, I guess that was you, Laurent, right? Then next? Or is it the other way around? Check the agenda for a sec. Second was DTN, so it's Anna and Edgard. Who's presenting, Anna? Is it you or is it Edgard? I see both of you are present.
Edgar that is presenting.
Okay, Anna, can you please try to press the button? Yes, share preloaded. Below your name, up there is a hand, which is join queue. And next to join queue, there is share preloaded slides. Can you try to do that?
My name. Can you repeat, please?
On the top left,
yeah.
there is a hand which is barred if you don't try to join queue, and then there is like a paper.
As to share slides.
Yeah.
Okay. Okay.
And you need to choose your deck. There are 3 decks, yours in the middle. Please pick it.
Okay. And share.
Yeah. And with that, you'll be able to scroll. Yes, it's being shared. Very good. So with this, you'll be able to scroll and go through.
Okay, great. So, yeah, this is a presentation about basically a problem that it was identified for mainly narrowband IoT. We can think that, I'm not sure if we could find exactly the same problem in other LPWAN technologies, but then we thought that it would be a good idea to discuss a little bit if it's a good idea to maybe have this as separate work or just include it as part of the narrowband IoT draft. Although I think Anna and me, we have been discussing and we thought that it would be maybe beneficial to split it in a different draft, because it's quite a different thing. But we can go through this first. So the main problem, so one of the things is to be clear. I mean, SHIC has been not so easy to be introduced in 3GPP. We have been trying a little bit to discuss offline. And then one of the problems that we have found is that the implementations of narrowband IoT and the hardware implementations, so the modems, are quite behind the standard. So they let's say they have taken the first release and they have taken only the, let's say, mandatory features, and that's the only thing they have implemented. So trying to save money, I mean, there is a lot of issues there. There is patents and so on. So then they try to avoid the implementers to pay more than what they have to. So then they actually reduce the number of features that they implement. Then that means that the user plane, which is the most powerful, let's say, feature in for cellular, it is not fully implemented. So instead of implemented the full user plane where you transmit data packets and normally like you would do in any technology, what is done is that instead of that, what is implemented is this data over NAS, which is a type of transmission where the data packets are piggyback to the control signaling of the control channel. So when you have a control channel and then you have mobility information, or you have a paging, or you have a reconfiguration of the device, so then piggyback to that, you can actually put some small pieces of payload. And this was meant to be used for very, very infrequent and little data. So we are talking about maximum kilobits of data. And there are several reasons for that. One of that is that the control plane, or the control channel that is used for this transmission, is a high priority channel, which means that whatever it's being transmitted there, it kind of gets a free ride in the higher priority queue. This is actually a problem, because if you have many devices which are using this channel, then what happens is that they might actually start to affect the cell capacity, because, as I say, the cell measurements and then the handover metrics and even the handover commands goes over that channel. So if you start to use that channel too much, then you are actually preventing other users to get signaling information. So basically, you are blocking other users with devices. So that's why this is supposed to be used only for very infrequent and little data. But then the reality is that, well, all the devices have this kind of firmware updates, and in some cases there are even these log files that need to be uploaded, or sometimes even downloaded. I mean, the firmware updates are of course downloaded and the large log files are uploaded, and then that is causing disruptions in the sites. So basically, people who are doing phone calls cannot do the phone calls because these channels are saturated. So then what the operators has been doing is that they are banning basically any large file transfers in narrowband IoT equipment. So there is no possibility to do firmware updates over there or software updates over there because they are too large to fit in this control channel. The problem is, of course, is that this is also transmitted with other protocols like TCP, and then you have retransmissions, and of course, if they are congestion, then the retransmissions make the situation worse, and the saturation of the channel is even, they call it a signaling storm, basically. So then that has caused that pretty much it's not possible today, or it's very rare that you can do firmware update of your devices over narrowband IoT, or even in some cases LTE-M, but it's mainly narrowband IoT is the problem, which is because they have the mandatory thing. So LTE, you would have to implement the user plane. For narrowband IoT, you don't have to. So you can go away with this only implementing the DONAS, the data over NAS. So then one possible solution is like, well, if the modems are going to continue having this, is why not to transmit these packets very, very slowly over a large period of time. And then the solution could be to enable this kind of delay tolerant transmission, where instead of taking, let's say, 10 minutes to transmit 10 megabytes or 100 megabytes, you can take 1 week. And then you don't have to deal with this also congestion problems due to retransmissions or synchronization mechanisms of protocols which are not delay tolerant friendly. Then the idea was like, can we utilize the same mechanism that SHIC has to transmit one IP packet, but instead of applying it to one IP packet, can we apply to the whole object? So if we take one object and then we divide it, let's say, in SHIC fragments, as if the whole object would be one huge IP packet. And then we would set up the whole timers and window sizes and so on accordingly to some kind of delay tolerant parameter configuration. So then we could actually reuse SHIC to provide this kind of delay tolerant service by using fragmentation services. And then a little bit the reliability if we want to use the, for example, ACON error, which for a mobile cellular network, it would be good enough. The idea is to have something like this. So you will have configurations which are mapping to certain, let's say, values of maximum packet size or object size. So then you could have in the uplink a configuration and in the downlink a different configuration. So it doesn't necessarily have to be the same. These configurations are agreed beforehand. Yeah.
There is someone in the queue. It happens to be me.
Sorry, I didn't notice. Go ahead.
Yes, I have a knee-jerk reaction, if you don't mind, which is, well, there are several things that you kind of asked, but not really. One is it something that's very specific to NB-IoT, or would there be interest in other technologies? Seems to me there would be huge interest in many technologies. I don't see why it should be only NB-IoT. Does it fit in this working group? I think it really does. If we need to recharter, maybe we do, maybe we don't. I would be pushing for that to happen. So very interested. Now, can we use SHIC as is? I don't think so, because you're creating a long-lasting session, and I believe that this should be formalized, in particular when the session breaks in the middle of 1 megabyte.
Mhm.
I don't know, it might not be 1 megabyte, but you want to be able to restart from there. So there are functions like this that will need to be added to Shake to make it what you want it to be. So I really believe in this work, but I don't really believe that you can say, hey, let's pick Shake as is. I guess there will be a study of what needs to be done to Shake. And with that, I will give the ball to Eric.
Thank you, Pascal, and thank you, Edgar. I think that's indeed a sensible problem to solve, and a real one, it seems. Now, I got two comments. One which is minor. There is a delayed tolerance network working group at the IETF, so we may want to change your vocabulary here to avoid confusion. That's easy to do. Now, I'm afraid it's, again, interesting work, right? But it will require rechartering of LP1 to doing it. And I'm a little bit concerned that we are going really into the transport layer. I mean, implementing finite state machine and so on. So I'm not sure whether this kind of work should be done in LP1 completely and not in another place into the transport area. So it's a little bit too early to think about it. So we can continue to work on this, of course. But transport problems are really, really specific.
Yes, but Eric, we already have retransmissions. You know, there are always this sort of thing on a short distance at a lower layer, like Wi-Fi retransmits up to 64 times, and we do retransmit some lost fragments. And the transport is this end-to-end thing, right? And they won't want to work below layer 3. And here we're kind of, what you're saying makes sense, but I really would like to debate that. I mean, there are pros and cons.
And the point of my issue, right? Especially if you have something which longs for many seconds or many days, what about congestion control? What about signaling? And then
actually, that will not happen. That will not happen, Eric, because it's one hop. So all the things which happen on multi-hop, which are effectively dealt with by transport, this does not happen. We're talking about one hop. Yeah, it's a very long-lasting frame hop, with right? many fragments, but still one hop.
Multiple hops, right?
Sorry?
Isn't there? Okay, anyway, so my only point, we really need, again,
let's have this discussion offline, but it's an interesting one.
The work, but we, at some point of time, the earliest as possible, we need to involve some transport people inside there, even if just to avoid conflict upon the charger. That's all my point. But continue the work, right? That's a problem to be solved.
Yes, and you can always say that, of course, this one object can be a very, very large IP packet. then we can have a philosophical discussion how big an IP packet can be. But then, of course, I agree that there are transport aspects to this, and one possibility could be that after very long time, let's say, what happened if the IP change? Could be a possibility. I'm not sure if it's feasible, but then it might be that you need to do some kind of, some kind of the change in the IP. Although the way how we have been thinking is that maybe to use non-IP connectivity for the case of narrowband IoT, which is very specific for that technology. So then, yeah, it gets complicated.
I don't think you should be saying it's one big IP packet, because it doesn't have to be. So don't make any assumption. You say what you said. I have this big file transfer upload, or I have this big firmware update download. I've heard that in pretty much every IoT use case I've been facing over 15 years. So these are really real cases. I don't think you have to place them in a single IP packet to enable Shake for that. So I don't see why you should make the assumption of single IP packet. And actually, it's a single session, but it could be different IP packets. It could even be a change of IP address, as long as you maintain the session active.
Hmm.
Okay.
Yeah.
Don't make too many assumptions here.
No, that was just half joke. So don't take it fully seriously. But then I think, I mean, there is matter of discussion how we want to model it and so on, because then you enter in the issues like, so what are we having? Chic over what? Is it IP? You know. So then I think that's the thing. Maybe we need to discuss further later offline. Most probably in the mailing list. Laurent, you had some comment.
Yes, just you are targeting at icon error, I suppose.
Sorry?
Are you targeting icon error for fragmentation?
Yeah, icon error mainly because at least for cellular, since there is reliability in the lower layers, I don't think anything else is needed.
Okay, so maybe that's a solution for when you close a session and start again. Is you can have a bitmap of what you have received or not. So maybe I think there is solution, and the adaptation is not that big to what Pascal said before. And maybe it can be used also to do some for control if we need.
Yeah, that's a good point.
That's good. That's very interesting point.
Thanks. And well, to finalize the presentation, so here are some examples of how this could work, at least in a cellular network. So you have the application connecting to the network, transmitting is a large object, and then the network would then do this kind of transmission, pacing it accordingly to the network scheduling that can handle for that specific site where the device is, so that you don't get the congestion. Then if there is any packet miss, so it can be retransmitted with the icon error, as we mentioned. So, and then finally, there could be a notification, but this is our details already from the network, so that telling to the application, okay, this object has been delivered. So in that sense, it's not fully end-to-end, at least not in this example, because you would need to communicate to the network, use it as a service to transmit this packet, and then you will get an indication saying, yeah, this was done for you. Of course, it could be done through IP proxies, and maybe then in that way could work something similar. And the uplink case would be a little bit more complicated, because there the device would need to kind of choose between the profiles. So it would have several profiles with different configuration, and then it have to choose the right one according to the let's say the object size that it needs to transmit. And then based on that, it would initiate this transmission. And of course, sometimes the network might override those configurations and say like, no, before now my congestion levels are different. Please use this other configuration, because we need to have even more let's say parameters which are more aggressive. But then the rest of the things are the same, pretty much the same. Yep.
Yes, I mean that when you write the prime, I hope you write a small prime statement which represents what you said. But when you write it, insist on that. I mean the kind of if there is any kind of congestion, because Eric raised that topic, that's not a end-to-end congestion that has to be dealt by the source. It's just over this hop. It's just slowing down. It's just feedback from this link. And we, on many radios, I mean, we look at DLEP, everything DLEP in Manet. I mean, we have this kind of feedback over the radio where the transmitter has to slow down just over that hop, and it is really way below transport, it's below IP. And here we are in the same situation as DLEP. having to slow down below IP just because the link changes, and that's fine. I mean, that's our job. But that's really where I'm saying it's not just SHIC. You have a session and you have to maintain it over multiple connectivity loss and come back, and so that's more of the, and yes, you have to basically adapt the rules that are used for that session.
Yeah,
so this is
when
where
I
the
mean
work takes place.
when I think congestion here is not like the same thing that you are
No,
referring.
yeah. It's more like DLIP. Well, DLIP is basically I have this router, and I have an external modem for my radio. Okay, it's not in a router, but I have a I don't know 100 megabit Ethernet between the router and the radio. If the router pushes everything it can over Ethernet, it will push 100 megs. But actually, the radio can do 1 meg. So if you don't have any flow control between your own radio and your Ethernet port, you're screwed, because you will push more data to the radio than it can send, and the radio will have to discard. So here it's a bit of the same kind of thing. The hop itself has to do some flow control, so has to do some rate limitation or something. And limiting the rate is a layer 2 property. It's not a transport problem.
Yeah. So what we do here is basically a rate limitation, so that you can actually have basically time multiplexing. So you can then do the more or more devices, let's say, at the same time, or more customers at the same time, depending, because of course you are mixed with all the others. That's the problem of the narrow IoT networks, is that they coexist with LTE, so they take also part of their they take part of their bandwidth. So then the problem is basically these data channels and so on. So then if you have too many of those users at the same time, so it might be that the network say like, well, wait a minute, I would need you to, because I'm feeling that I'm kind of reaching some level of too many users at the same time, of concurrency. So then use instead these new parameters, so that when you are gonna send an object, so then you are even having more aggressive parameters for that. But that's it. So, but then you don't do changes on the middle of a, most probably you don't need to do changes on the middle of a session. So once you have started a session, I think the network can handle that and is taken in account. The problem is beforehand. So then that's what the network might preemptively change the parameters and then do this kind of dynamic configuration. And that's another thing that is a bit different with the SHIC nature, because SHIC is supposed to be quite static. And then here we are having these configurations, which are, they might be static, so they might be already set beforehand, but then you might need to choose between them and so on. So then in that sense, it makes it a bit more dynamic than it meant to be in the beginning when SHIC was.
Edgar, I have to ask you to conclude.
I have concluded now. This is the end of the presentation. So thank you.
Oh, very good. So let's continue on the mailing list. I mean, I can see Eric's objections, but I think we can work around them. It's just that it might be bigger than help you. I don't know, because it's not just, you don't really use SHIC as a compression mechanism, and SHIC would become the thing for everything in BIoT that needs big data. That's huge. Okay. Anyway, so Anna, yes, please. Anna?
Do you hear me? Yes.
Yeah.
My question is, I see that there is, we are interested in this work, and only to finish the presentation, do we add, or do you think that we need to add this work in the same draft of NB-IoT, or?
No, you cannot do that.
No.
You need to complete NB-IoT first, and for this one we need a prime statement, then we need a recharter, and it might or not be accepted, and by then NB-IoT must be published. You need to publish NB-IoT. I hope
so
Eric is with me on
we
this.
need to create a new draft.
Yeah, starting with the
draft.
prime statement, we need to architect this thing. It's not very clear exactly how we do things.
Okay.
Okay, so then now it's clear. We've started a new discussion on this one. Thank you, Pascal.
It's like Eric said, we are not even chartered for it at this time. So
Good.
okay, and Laurent, so can you please, Edgar, stop sharing? And Laurent, can you please do the same? Okay.
Okay, I make progress now. I succeed to upload the slides. So it will be a very short presentation on how to augment the SHIC young data model. So it's just because we had some discussion with Juan Carlos this week on how to do with Componac. And so the goal is maybe not to document, but to discuss about that. But because I'm not a full specialist of Young, so maybe there is things that I don't know, but yeah, I will tell you what I have learned. So the first two steps is to read the very nice RFC 8407 that describe how to put a Young model for the IETF, and especially that how you name things and how you put it into RFCs and draft. And also you need to install Pyong, which is a very important application to test your Young model. So the next slide is just to show you how we did for Componac. And so do you see the mouse when I'm showing things or
No,
not?
Laurent, you're not sharing your mouse. Actually, you're not sharing your screen.
Really?
It's just no, you're not sharing your screen. It's
Oh.
only I uploaded the slides to Mitico, and then you selected them, and you can scroll them, but
Yes.
it's not your screen.
Okay, so how do I do? Because I send stop slide share. I have.
But
So,
by the way, Laurent, just to be clear, we see your slides.
okay. Okay, so that's good.
I'm sorry I wasn't clear. We see your slides, but we are not seeing them from your screen. We are seeing them from the upload.
You're remote controlling the slideshow, not moving
Okay,
the
so we
cursor.
cannot show with the mouse. Okay. So when you create a new model, for example, for SHIC Componac, so what we did is to put SHIC at the beginning to remember that it's something that belongs to the SHIC model, and we give a prefix that can be used after in the model, that is SHIC Componac. And then we import IETF SHIC, which is the document that we wrote and described the data model for 8724 and 8824. And then when we want to define things, for example, here we define a module, leaf value that is bitmap format type. So we do it as usual. And the last thing, you have augment. And in augment, what we specify is the identifier of the element, and we put SHIC at the beginning, which refer to the fact that it's in the IETF SHIC data model. And in this example, we add a leaf, and this leaf is bit format, and then we have tests. So that's the way to extend the Young module. So on the repository, there is one for Componac and another one for OIM. So you see, it's simple. Yes, Juan Carlos?
Yes, hi. Thanks, Laurent. So I'm not an expert either on Young model, but then what I understand is that this text that you are showing is the only part that we would need to document in the Chic Compound Act draft, right?
Yes, you have to add at the end something that starts with code begin and code ends with the name of the file, and then the content is the young model.
Okay, but then and is there a common way of doing it? Like, does it have to be in the body of the draft, or is it an annex, or who cares? You know?
I don't remember if it's an annex or in a body. What I did, I use MD, and with MD you can include a file. So this way it's very easy to do. I don't know for full XML if you have to copy it.
Okay. All right. So I guess then the question would be to the chairs, because we have the Chic Compound Act draft after last call, and we got a couple of comments. The ones on the bitmap and stuff from Dominique, I think we know how to address them, and we have a proposal. And what the question that we still had was how to move forward with this Chic Compound Act. So my proposal would be to include this text, as Laurent is saying, showing it in the document, and then publish it as a response to the last call that we had. And I don't know if the wish would be to do another last call, or to request comments, or send it for review with some directorate, or what would be the next step.
I don't know. I don't think we need another last call for the young data model, right? But maybe we said we could trigger, like we did last time, a review by the young doctors, or I mean, Laurent, what you did please say, or is it this tool, that Pyong, that you asked about, you discussed? Because I understand you can run a tool on the draft itself, and it will say if the embedded young is correct, right?
Yes.
Is that Pyong? Is that what Pyong
So
does?
I think when you put something with code begins and code ends, you upload it, there is test on the young model. But with Pyong, you have a -- IETF mode on test if the young model is conform to IETF specification.
And it's all in 8407, right? You say there is RFC 8407.
Yeah.
It's all documented there.
Yes.
Eric is. Yes, Eric, please.
Yeah. So, Juan Carlos, one easy way is to use the youngvalidator.com website, where you can upload either the module itself, so the few lines we see here, or the complete RFC as a .txt, and extract the module from the TXT, and then you can check the validity. It's also using Pyong and other validators if you prefer. And I concur with Pascal. Nothing is changing really on the protocol itself here. So I don't believe a working group last call again for 20 lines of data model is required. It should be on paper, right? Because it's changing normative text. But just for 20 lines, not changing the protocol itself, I will not do it.
Okay. Okay, so I will coordinate with Laurent, because I guess he's more familiar with the young models and the tools. And once we have the new version, we will publish it and announce it on the list.
But Laurent, when you ask some help from the young, I'm getting feedback here. When you asked the young doctors, they reviewed this piece as well, right? Because it was together with the rest at the time. So it has been reviewed, kind of. Is it correct?
I don't think this young model has been reviewed, and for the Chic, pure Chic young model, it has been reviewed a long time ago. And
it was before Compound.
Yes, and so they give me very good hints and to progress in the way to write young, but we still need a more detailed review now.
Is that something which will naturally happen during the ASG review? I guess so, Eric? If you have Yang, I expect there is a Yang review as part of the ASG review.
There will be, during the IELT review, there will be a Yang review by Rob Wilton, which is the Ops AD in charge of Yang. And most probably, if I remember, I will request at the IETF last call to the next step, a Yang doctor review on this one. And suggesting basically to reuse, I don't remember who did it for the first early review, or asking for.
Okay, so that tells us that we can really ask for publication. I mean, once Juan Carlos has addressed all the issues and added and my main issue was the data model itself. So once all this is addressed, we can ask for publication. I mean, as soon as Juan Carlos publishes, I will press the button, right?
Yeah. The better, right, in ideal work would to get the normal data model from Laurent and Anna and Juan Carlos extension requested for publication roughly at the same time. So I can build them together.
Yes, it makes a lot of sense. Yes, I see what you're doing.
It's not delaying something for weeks, right? And anyway, as this Compound Act now depends on the data model, right? There will be a cluster after IAG evaluation. So they will be published at the same time.
Yes.
Just to be aware of it.
So Laurent, it's the ball is in your camp. I mean, when do... Because the last call from this group won't tell us a lot because none of us is much of an expert of Yang. So, I mean, we'll have to trust you on the detail. We can look at the data, but we'll have to trust you on the formats and you.
So for me now, the model is the full SCHC data model is complete. So we can go to review.
We can publish.
Yeah.
So Dominique, being the editor of the SCHC document, did you make a pass on the completeness of the data versus Appendix D or whatever? Yes, I guess it was Appendix D, right? Of the SCHC spec, is it complete in the terms?
You mean comparing Appendix D and the Yang model in this
Yes.
draft?
I would like to see that done by us before we publish, but after that, I'm ready to press the button as well.
Okay, to be honest, I haven't done that. I'm still struggling to learn Yang and understand it fully. So,
me too. But it's more like expect that Laurent did the right thing about the structures.
right.
Just make sure that the data is there. Like for every entry in an XD, there is a field in this data model. Is that something you could be doing for us?
I will do that. Yes.
And Laurent, you published, right? So if Dominique says okay, we're all okay, kind of. Because you published the latest like a few days ago, right, or yesterday? Yes. So basically, what I suggest is I'm waiting for the Dominique to say yes, I found the entries for what I think is necessary, and then we get the Juan Carlos to publish his new version, and then I will press both buttons at the same time. So there's a chance to bundle them, as Eric said. Are we okay with the plan? Does that work?
Yes.
Yeah.
We're okay with the plan. You just did not announce a deadline for that.
Yesterday. No, but it's really Juan Carlos. I mean, what can you do? And Dominique, what can you do?
I guess we could. My wish would be to publish this week.
Within how much time? How much time do you need to publish your new version, Juan Carlos?
So, if I can coordinate with Laurent and the rest of the authors, again, I guess this week in a couple of days, but let's say end of the week, right, the latest.
Okay, so early next week, Dominique, do you have a chance to make a pass before next week? Then the target date would be a week from now, before Christmas. I mean, sometime before Christmas.
Okay, if I make this our top priority for this working group, I can do that.
That's nice. Okay. So the objective is we push the buttons for both drafts sometimes next week, depending on exactly what you could do. That's great. So thank you very much. That's really huge progress. And now we'll have those milestones this year, which is nice. Okay, and I guess we've passed the hour. So thank you all very much for all the great progress that we've done recently. And this group is still rocking, and I hope it will keep rocking next year. So looking forward to talk to you again next year. Bye-bye.
Thank you,
Bye.
Pascal.
Bye-bye.
Bye.
Thank you.